And Chiara made a comment about, you know, in the past camps, we have seen paper clips used. We've seen pipe cleaners used. The preferred method would be to use insulated wire of some sort. So, but you could go as simple as speaker wire. You could go as simple as just a single stranded wire that is small enough gauge to fit in the breadboard is really what you're looking for. Solid wire is definitely preferred, and you would see why if you tried to use stranded wire very quickly.
Thank you. Yeah, so you can switch it up, but I think for the most part, like basics wise, if your girls aren't that advanced, you just want to tell them background white.
I saw plenty of extra wire that somebody obviously supplied in many of these hats that were done in camp too. A lot of extra wire, because I know we didn't give them that.
Well, then that'll be helpful then. Yeah, that'll be good. And yeah, like we talked about, this black wire is this thing right here that just connects all the way down from your board to your computer. Then you're gonna talk about our LEDs. So like I was showing you before, we have our long side and our short side. So our long side is the positive side, and that's called our anode. Our short side is the negative side, and that's called our cathode. So this will depend, like you'll usually sometimes put this right into here, into your breadboard. So that's what we're gonna be doing for our LED. You can do it other ways too, but for the LED activity, that's how we're gonna do it. And that LED activity will be done on Tuesday. So then this is our resistors. These are right here. And they kind of, it's like if you want to think about it, it's like your mom and cookies, right? So your mom's like, no, you can't have another cookie. And you're like, well, I won't, you know? And it's like, if you have too many, then, you know, you might get sick, right? And so if you have too much power going through your circuit, then it's gonna short circuit. It's not gonna work. But if you have just enough, or you delay it just a little bit, it'll work out well. So if you want to think resistor, think of your mom, right?
No more cookies.
No more cookies.
No more power.
Only pizza on pizza making.
Less power. Yes,
yeah. So that's how you can think of that one. Servos, these just pretty much spin around. So you can have them spin around 180, you can have them spin around 90. It depends on what code you use, and like we'll talk about that soon. So yeah, these are our servos. They just pretty much spin around. They're like a fan kind of. And so yeah, like you see here, it says you can move around 360 either left or right. So depending on how you power it, you can move it left or right. Some of them you can, you know, make it so that it only goes 90. Some of them you can make it so it only goes 180, and then it goes back, and then it goes forth, and then it goes back. And so that's how those work.
And the bigger one is the continuous. The smaller one is the positional servo. So in your kits, you got 2 servos.
Yep.
One, and oh, by the way, don't twirl them. Don't try to twirl them manually. Don't, and tell the kids that, and warn them and warn them and warn them not to do it.
Yep. So yeah, like Dr. Mimi was saying, thank you for pointing that out. So continuous servo is 360 around. Positional servo is the one you can change the range for it. And here at the end of your servo, so when you pull it out of the bag, right, it just looks like this. It's just this and this, and it doesn't even have this. It's just like that. So then you can add, you know, one of these blades to the top of it. You just stick it on there, and it clips right on. And now you have it like this, right? And so when you look at these wires here, you see a white one, a red one, and a black one. So the red one here is power, the black one will be ground, and the white one will be used for signal and control. And so that's what we're going to use these for. You're going to connect these into these, and then you connect it into this, and then you're going to make your servo work. So I'll show you guys how to do that in a sec.
Just a comment on that too. One of the biggest challenges that campers have run into with either usually they're continuous more so than they're positional, is trying to put too much weight on it, or putting weight on it that is imbalanced, and therefore it takes more torque to get it to turn because it's offset. So those are the kind of things you're going to have to work through with them. These are very small motors. They don't have a lot of power. So if they want to put something rather heavy on it, it's going to be a big challenge for the motor to work. So just keep that in mind as you guide them forward with their ideas. Styrofoam balls, paper cups, those are the kinds of things that are realistic. But if it gets a lot heavier, and you'll be able to hear it more because you'll hear the motor working harder to try to turn.
Yep, definitely. There's not too much weight on it. It'd still be too much pressure on it. Yep. So then we're going to look at this a little bit more deeply. So this again, our microcontroller right here. And like we were talking about, these are digital pins, and PMW stands for pulse width modulator. So these are like used for control of brightness with your LEDs. They are speed control. They are controlling your servo motor. And this is where you put in your digital pins. Then here again, digital pins. So they're used for control of electronics and make them behave a certain way. Sorry. So pins 0 to 13 and digital ground are digital pins. And over here 0 to 13. So this is our reset button. So sometimes some girls will have a hard time. You could just tell them, click your reset button, check your code, go through everything, make sure your connection is working, unplug and unplug from your computer, replug it to your computer. Sometimes things happen with our code and like the app we're using. So I'll show you guys how to fix that really quickly. But anytime you have an issue with a student and it's technical and you look at it, you see it, you can't really figure it out, send them to the main room. Dr. Mimi will be there. There'll probably be other people there to also troubleshoot and help out with those problems. I will maybe be in there too. And so we'll be able to help them with those problems. We'll go through it with them. We'll check everything. We'll make sure that everything is working properly. And sometimes it doesn't work. And it's just a technical error. It's no one's fault really. Just things sometimes kind of happen and we can't really control it. But just encourage them to keep trying, to keep unconnecting, reconnecting, trying all the options and sending them to the main room. And if we really can't figure it out on the main room, we'll figure it out the next day or the following day. And, we'll work with them and try to figure it out. But we really want to make sure that everyone has a chance to, do their hat, figure everything out, put in their LEDs, put in their servos. And so, yeah.
And occasionally you're going to run into a problem where they have a faulty piece of equipment. Not very often. And usually I have to say this again and again and again. It's usually the connections. It's not usually the equipment itself, but we have had instances where if motors start leaking fluid, if you start seeing stuff coming out of your servo motor, then that probably has an issue. If you consistently can't see a light on your Arduino board when you plug it into a power source, there's probably an issue. So you should immediately be able to see minimally a power light, even though you haven't sent any code.
And something that I actually learned today from a different camp is you can short circuit the 5-volt pin. So what that looks like is the Arduino board will light up for maybe a couple seconds and then it'll shut off. So if that's the case, it's most likely one of the power pins is just fried. So troubleshoot that by unplugging something from the power rail, usually 5V or VIN, and that should fix the issue. So that never happened before, but it can.
So it's
So-
just a temporary short circuit gets set up, or does it burn out? It doesn't burn out the Arduino board, or it does?
No, it just burns out that pin. So that pin is done for. So
Oh, so then all you have left is, if it's the VIN, then all you have left is the 5 volt?
correct. Yeah.
Okay, okay,
Interesting.
good to know.
Really quickly, I want to add that the reset button, that white button, is different from the reset pin. The reset pin is a little hole, just like the numbered pins. It's a little hole, it says reset next to it. Do not stick anything into that pin, because that will reset the entire board, and that's different from just restarting your code. That's
Yeah.
going to reset the board.
That reset pin is right here, so you don't want to put anything in there. You'll just click this button if there's an issue. And this is your US. Oh, sorry, I cut you off. Go for it.
Sorry, I just really quickly want to add the pins with the little squiggle. I just call them the pins with the squiggle. Those are used for anything involving a particular value within a range of values. For example, when you're coding for your servo, the positional and the continuous servos, both you have to pick a value between 0 and 180 degrees. And so the squiggle pins are the ones that you're going to use for the servos, because you have a range of values to choose from. But because the LED is just on and off, you can stick that into any pin. I just wanted to clarify what that meant. Continue. Sorry.
Great, thank you. So this is our power. So if you were to use like a battery, you would plug it in right here into this part right here, our power supply. So that'll be used for your batteries. This is your USB connection. So you see how I have it plugged in right here. That's your USB to connect it into your computer. These are your power pins and your analog pins. So here, if you kind of zoom in, you can see that it says like, it says on these ones, it says A0 to 5. So that's how you know they're analog pins. On the other side, these are our power pins. So that was that reset pin that we're talking about. Just don't touch that. Don't even mention it to them. They probably won't really know much about it. Don't talk too much about that. But this is our 5 volts pin. So 5V right here. We're going to be using that one. We're going to be using our ground. Ground is like for negative or ground. So it's like our negative side or our ground side. This is our VIN, so VIN. So this is our positive side. And yeah.
By the way, VIN, voltage in. That's what that stands for, voltage in.
Yeah. Any questions?
I had one and it went away. It'll probably come back. Oh, I remember. So campers, really, the battery pack should be the last thing they start worrying about. That
Yeah.
should be just before they should always be plugged into the computer, if at all possible, because you don't want them draining their battery. And if you get a couple of servos or a couple of LEDs on there and you forget to turn them back off because there are no switches here, it will burn it out pretty fast. So you definitely want them to keep it tethered to the computer most of the time until right at the end.
Thank you. And these are safety. So you can go through and, go through all of this again later. But for the sake of time, I'm just going to rush through it.
Has anybody in this group got anything smoking or got anything hot to the touch? Any of the coaches out there in the camps, the past camps? I'm looking if anybody did.
I see Anushka has her hand up.
You did, Anushka? You got it hot to the touch? Which part?
Yeah, I think it was my continuous servo. Yeah, it was a continuous servo from last year's camp that I just had left over and I was using. And that became hot to the touch, and a couple of days later it stopped working. So.
Oh, interesting. I suspect they're all a little bit sensitive. So how about you, Iris? Did you have anything happen where things got hot to the touch?
Not hot, but it stopped working. It was like the continuous and the positional.
They're
I
fussy.
figured, What?
They're fussy.
Yeah. So I had leftovers from last camps.
Uh-huh.
So I just took those and they seem to work better.
Cool.
the
That's
rest of them.
Good deal. Okay, keep going. Thanks.
Sure. So we're gonna go over the LED circuit. This is gonna be like our LED activity for Tuesday. And when it comes to me reviewing all of this stuff in our, in our main room next week, it's gonna be a lot slower, a lot more like, point A to point B and not really, too confusing. But for the sake of time, I just want to go through like the slides really quickly and show you guys everything. But yeah, so this is going to be our LED circuit. These are like when you're writing out your when you write out physically, like physically write your circuit out, this will be used for ground, this will be used for power, this is your Arduino board, this is your resistor, these are your LEDs. So these are all the symbols. And then when you connect them to other things, you would use like a straight line, and then you'd connect it to like a resistor, and then you'd do a straight line, and then you'd have like a box here, and that would be your board, and then you'd have a straight line, and those straight lines are your wires. And we'll go over that in a little bit, but these are like your for when you're writing things out, these are your little symbols to use. Then this is what it would look like. So this is like the lines that I was telling you about. Here's your resistor, then here's your LED symbol, keep going down, wire all the way around, power. So these are symbols. This is how you turn it into a circuit, and this would be like a functioning circuit.
Christy, you have a question?
Yes. Am I unmuted?
Yeah,
You're
you
good.
are.
Yeah. Okay. One of the questions I had is, how do you decide when to use the 5-volt or the 3.3 or just the VIN?
Well, so the LEDs are somewhere around 2 volts a piece that draw on them. And so if you, and I forget what the motor is, I keep meaning to look it up and I haven't, but the 3.3, you may not have enough threshold voltage to actually flip the LED on if you have a motor in there too. So I think that it's just the size of your circuit and what you have in it. Really, 5 volts versus 3.3 volts.
I also learned last camp that you don't need to use a resistor. I mean, we teach the resistors
Yeah,
for girls to,
I know.
but for the digital pins, at least for 13 and 12, you don't need a resistor. So if the girls are trying to get creative with their wiring and not use a breadboard, they can do that.
That's cool. I actually didn't know that. That's cool. Yeah, so these are going to be the required hardware. So when you get onto these slides,
Hang on a second. Now, Letitia asked whether the morning sessions will be recorded. No, but I've been thinking about recording this camp because I've got a couple of students. I was going to record at least one day on Wednesday in the main session, but most of the work gets done in the breakout sessions. So unless somebody records a breakout room, we typically don't record in the morning sessions. Okay, keep going.
great. So when you look at these slides, it'll tell you everything that you need. Like, so it'll say before you start required hardware, and then it'll tell you, here's our required things that we're going to be using, right? And this is where you're going to plug this into. So you're going to plug one end of your red wire here and one end of your red wire here. You're going to put in your black wire here and your other end of the black wire here. So just like how Dr. Mimi has it. Yep. So one side will be used for one thing, the other side will be used for the other thing. And it tells you, it'll say like, oh, here, it says, okay.
And extra wires.
Yeah, and I have Dr. Mimi spotlighted, so
Okay.
everyone should be able to see her.
So you'll grab your red wire and you'll stick that right into V5. So that's going to be on your Arduino board, your microcontroller. And the other side of your red wire will go right into row 5 of your breadboard. So that's the white big board. You're going to have your black wire. You're going to connect that into the ground of your Arduino board. And that's, if you go back here, so that's right down here. So one black wire here. Your red wire will be right in here, V5. And then your ground will be right here. So then if you go back and then you look at your other side of the black wire, that'll go into your negative rail. So we talked about that in our breadboards. That's going to be, where's our breadboards?
This will be, I can't tell you how many, when I looked at the setups that campers had, how many were not in the negative rail or the positive rail, and they thought they were.